Yeah, making a video. Physics kind of stuff, I think. And yeah, I don't know where I'll put it, but whatever, doesn't matter. It's two slate stuff, whatever. So the Carla Stinkpot made some sort of snarky comment. I just want to respond to it. He doesn't need a counter argument to your quantum science denial. So he's calling it quantum science denial, and I'm not doing that. I'm just saying probability doesn't mean something is doesn't have a location. That's all. When the experiment that you proposed in your last video to test the hypothesis already been done and falsified your hypothesis? Well, I don't think, number one, my experiment wasn't done. Number two, if you look at the results, I don't know if they do exactly falsify anything. That the pedestal between the slits somehow interacts with the photon differently when one slit is closed. I linked to it, for fuck's sake. Yeah, and I looked at it, and I was going to get to it, but apparently you're so impatient. I was supposed to make a video immediately. So I've had the tab open for 2 days. Ooh, sin. But you ignore it because you have no clue of physics, but won't admit it because your ego is too big to admit that you are wrong. Well, whatever. I don't think there's evidence that I'm wrong, and I think as I go through this more and more, it's going to become more and more obvious that somebody else is wrong. Yeah, a lot of people are wrong. Really wrong. Anyway, so yeah, I have it here, quantum, I have the Nova thing. Where the hell is it? There's the PDF, which is really a bad PDF. So here's the images that there is a video of. And there's a lot of complaints you can make about this, the way they did this. These aren't in the video. Well, I mean, there's no clean progression of this thing they moved here. They moved it at different amounts. They went from 1440 nanometers to 2320, then to 25, then to 2540. These numbers are completely, not, they jumped 1,000 here, 1,000. Why? Why not just do the smooth transition? It's just reeks of, you know what I mean? Anyway, so this is with only a tiny fraction of one slit exposed. And you gotta say to yourself, well, look at all of this. Look at all this. And there's only a tiny, this one is no slit showing at all. And look at all these little spots here. So it seems obviously the interference is happening before this partition, which means it can't be happening, it has to, technically the interference should be happening here throughout this whole movement or migration of the wave. The interference pattern can't happen at the two slits because the two slits, even if they were water waves, haven't had time to interact yet. So if you have a barrier here, and your slits, your wall, your target is here, there's no opportunity for interference. So where's all this coming from? Look at all this. Again, this is with barely one slit open, barely one slit exposed. Now this is one slit exposed. Look at all these. Look, I mean, I don't know. Maybe you can't see this, but I mean, these are glaring, okay, glaring artifacts. One slit completely exposed. Look at this. Okay, and one completely covered. And you're telling me that's definitive proof of something? Well, I think you're a long way from definitive proof. And technically, these bright blotches, if they went just through the one slit, they technically probably should be over further. So anyway, I don't think you have evidence here. If I find the video page, let me just see if I have it. The video is just, yeah, you're just sitting there saying, well, wait a minute, that doesn't really say the story. So here's one slit completely open, the other slit completely closed. And like I said, I don't, this isn't going to pick up great, but you can see that. Huge artifacts, and the bulges, you can see the brightnesses in here. So yeah, if anything, this has validated my point. There's no opportunity for interference. The cover is close to the slits. So there's no possibility. And I don't even know why they did this with an opening. Why didn't they just put a partition that goes across? Even better, why don't they just make it so the two slits can be moved into the light beam, slowly migrated in and out of the light beam, and then we could really see what's going on. So anyway, but obviously my experiment was to put this partition before the slits, because I don't think there's any point in blocking them now. But I guess, like I said, this is sort of pointing out that you already have the development of an interference pattern with just one slit exposed, and you know, that it doesn't have time to interfere. And even if you said this light from here is reflecting off the barrier and then reflecting and then reflecting and then reflecting, and somehow there's no way for it to get, oh, you know, here, 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 here. So that doesn't make any sense. So I'm just saying this doesn't prove your case. It seems to prove mine. But anyway, is that all I wanted to say on that? I mean, there's a lot of reasons not to like the way they did this experiment. Like I said, I don't. The fact that they don't have an even progression is, you know, that's just bad. I mean, I'll play the video and you can see it in the video. It's only 22 seconds, so I think we can handle it. Start at the beginning. And if you just watch, like, I don't know if you'll be able to see it, but this thing goes, jumps right in the middle. Right in the middle, they decide to jump. Jump! Yeah, so I don't know what that was about. But doesn't seem like the right thing to be doing. Anyway, look at that. Look at all those artifacts. When the dimmer it gets, that's almost, with both slits almost covered completely. So anyway, yeah, no sale in terms of proving anything. All right. So what I'm going to do is, you know, I'm probably going to augment it before I post. Well, after I post this video, I'll probably change this. I got so much crap on my mind. So anyway, I wrote up little bits of stuff here. I'll highlight this stuff and make it bigger. These are just like key points, and I'm trying to figure out which ones are hard facts and which ones aren't. So I don't know if you can read that, but close enough maybe. The light is still light in matter, so that's the crux of my theory, but it's not necessary to this complaint about quantum mechanics or the two-slit thing. This doesn't have to be true for that to be still a relevant argument. But I just think this explains what's really happening. When light's interacting with matter, it's interacting with electrons, and electrons are made of light. Matter is just captured light. Okay, photons moving transfer their movement. Energy is never consumed. So what you're really just doing is transferring movement, the energy to move, the information to move. So even when like kinetic energy goes through those balls, you know, the kinetic balls that swing back and forth, the energy, the impetus to move is transferred through the transition ball, and then the other ball moves, because you can either transmit the information to move, the vibration to move, the change in the matter, or not. Anyway, photons interact with electrons. That should be, we should be able to establish that as a fact. Direction/momentum can be changed through capture. So this is the whole idea that the electron is basically this thing chasing its own tail, but it doesn't quite reach it, and so I'll draw some pictures of that. Energy equals movement of stuff, so that's kind of all you need to know, and stuff is photons, so the energy is just photons. And you can trap the energy and call it potential energy, like in an atom, or you can release the energy and liberate the photon and call it kinetic energy, as in a photon. All action is just a change in a direction. So action is a tricky word, but I mean all change is what we're talking about, and it's really just a change in the direction of the structure. Change in net balance creates momentum. So acceleration is a forced shift in direction. So that's another part of this. This stuff really isn't critical to the two-slit, but it's critical to, I think, the contextual overview of what's going on here. Alright, so I want to stay with the two-slit for now, for this moment. Maybe I'll do this in two pieces because I have shit I gotta get done. Yeah, it's getting late. So we'll do the two-slit part and then I'll do the other part later. Alright, so let's understand this two-slit thing. So first you have a source of particles, and then you have an aperture, a hole that you put them through. And the physicists say to us this is where the probability wave is created. So this is where photons get all rigged up, and now they're in 14 places at once and don't know where they are. Okay, instead of recognizing that there's this diffraction thing that happens, and that the particles are by percentages of the interacting surfaces, will create this pattern. And this pattern just comes out looking something like a typical belt curve. Alright, the probability of the photon being here is here, and the probability of it being in the middle, let me just draw it better so it's more like that bell, and the probability of being here is here. Okay, so there's a high probability of it being in this center area, and a lower probability of it being down in one of these outsides, these far extremes. There's no possibility of it being here or all this other crap. Can't be anywhere. The math works out to, you know, 0.000000 for almost ever chance of it being there. So anyway, so they're basically just saying that instead of it actually being one of these locations, it just doesn't know where the frick it is, and it's just could be anywhere in here, and it's not anywhere in here really. It's a wave now. So it's just it's a wave. Maybe it looks like this. Okay, so it's a wave that doesn't even look like a wave. It looks like a bell. And just heading out towards now the two slits which are here. So we're talking really about the impediment is the key thing that's different. So you have a big, a big and a small, and that's the trick of this thing. So this wave now is going to head for these two slits, and the point is that the probability goes through both the slits and interacts with itself and creates a bar pattern over here with, like, this would be the, say, the 16%, this would be the 8, and this would be the 4, and this would be a 2 or something like that. And these would be 0, 0, 0 in between, or something close to, like, obviously they don't come out to 0, so there would be some lesser percentage because you never see a real clean 0. But anyway, so instead of just saying, okay, the stuff comes through here, the aperture is really small, there's a high probability of interaction with this surface. The surface is made out of electrons. The electrons bend the course, change the course of the photon, so the photon actually has a path. It actually goes through one of the slits. The slits are again designed to be narrow enough to maximize the probability of interaction with the electrons that make up the surface. And this surface is obviously going to be electrically different than these big surfaces. That's what happens with electricity. It's different in the size of something, makes a difference to its electrical potential. So anyway, and the idea is that most of the photons are probably going to be in this area. So that's, the beam has been focused to maximize interaction with this center. I think it has been anyway. So that's one thing we could use as an experimental. They could show us, they could just put the photographic plate in front of the two slits and show us the pattern of the light, its size, its dimensions, and then we could know if the two slits, where the two slits fit, or the one impediment, where the one impediment fits in that beam. And my argument is that if this was the impediment, and here's the walls, that the beam is something like that, that 90% of the photons are going to be very close to that center impediment that is the most electrically active. And that, so their theory is it's a wave here, it doesn't know where it is, it doesn't know where it is, it goes through these two slits, it interferes with itself in these other dimensions. The dimension X interferes with dimension Y and somehow produces a result in this dimension that reflects the interference. So somehow we communicate with the other dimension and we get a result based on that communication. That's their theory. My theory is this aperture creates electron impact with photons. It deflects the path of the photon. The slit is electrically active. It creates impacts on the photon and deflects them in set proportions, and those set proportions are reflected in this pattern. Yeah, that's my theory. Yep. Okay, so yeah, that's enough of the two slit for now, I think. And so anyway, the experiment I was suggesting is being able to slide a block in front of the slits, so that you would retain this smaller slit's impact. Because you can't, if you just close the slit, then if you just close the slit, then you're just creating, a bigger. Now you're just turning this into a wall, and so you now eliminated the electrical activity of the smaller matter. So the tension now is different. The electrical tension is now two big surfaces instead of one big surface and one small surface. So you change the tension, which is likely to produce a change in how much diffraction there is. More diffraction, smaller surface. Well, it doesn't. It's not necessarily smaller, as they found with the glass experiment. So let's do the glass thing again. The idea of the Newton glass is that glass is supposed to be 4% of light reflects off the surface of glass, and this is monochromatic light. So each color light, red, yellow, and blue, will change its reflectivity based on the thickness of the glass. So if the glass is a tiny bit thicker, all of a sudden this goes to 8%, and if it's a little tiny bit thicker, it goes to 16%. So that's the thing, and it just keeps doing that cycle. So no matter how big you make it, if you make it a tiny bit thicker, you'll change it by this same proportion again. Another increment of ratio change, and it just keeps cycling through that cycle. And I think this is a reflection of the same phenomenon. As this slit diameter changes, you're likely to change what kind of pattern you get here. And so this has been maximized to create probably the biggest, some sort of 16%er, to make it most dramatic. Something like that. Yeah. Alright, so anyway, that's enough on the two slit. So I'll add some other stuff later. Alright, let's finish up, see how long these batteries last. Sorry, I had to do a Puro video in between. Anyway, morning now. Anyway, so I just wanted to update. I'll just go through some explanation. I don't know how related this is exactly to quantum mechanics, but it's related to the idea that we have to understand how matter is held together to understand why photons react a certain way when they contact matter, right? You can understand that statement, right? Matter's where the complexity is. The simplicity is in the photon. Common physics theorizing is the photon is doing some sort of magical multidimensional thing, and the matter is some sort of static thing with which has no variables, no changes, no aberration whatsoever. It's always the same. Every single surface is exactly the same material. That's sort of what physicists have concluded, and I think it's preposterously silly a conclusion. And this will be part of the explanation of that. So anyway, there's a conventional understanding of atoms. The conventional model is just an old guess that it has these standard orbits. You got a center, and you got these orbits. I don't think that model's correct. I think it was just made up. It was just a guess. You know, that's all we can do with this shit is guess, because you're never going to make a telescope or a microscope that's going to give you visions of these things. So anyway, people just have to guess, and they have to guess in some sort of way to model this thing. So, but let's understand that there is no surface of matter, right? And it's all like this is all just matter. You know, we know that the matter is made up of atoms, okay, and the atoms are in arrangements to each other, and that they're constantly moving, jiggling, and it's very hard to stop them from jiggling. I mean, even if you make them very, 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 very cold, you'll still have atomic movement, because that's the nature of it, apparently, right? So we can say that this movement thing is something built into what an atom is. Its basic nature is vibration, movement. It's not doing some kind of, I'm all happy, everything's centric, everything's perfect, everything's just fine, I'm just stable. There's no such thing as that kind of atom as far as we know, as far as the evidence indicates. So anyway, my theory, okay, that I used for a different purpose, alright, so I thought that, okay, there might be some other mechanism that's tying this stuff together. So I theorized that an electron is really, you could say, photons in a double helix. And that accounts for the trapping of photons in this mechanism, because now they don't have to go the speed of light perceptually, because their speed is used up in their spin. So the faster the electron spins, the slower it moves in this direction. The slower it spins, the slower it spins, the faster it moves. So it goes slow in this kind of movement if it's spinning fast. It goes fast if it's spinning slow. Alright, so that accounts for the speed of light being a constant. So you maintain the constancy of the speed of light. Then my second model on top of that model would be that electrons in atoms tend, that there's maybe in the nature of this spiral, it creates an inevitable bending, and so they end up bent. Okay, on them, like in a circular spin, and that's their nature, is to be in another spin. You know, that's relevant to this circular thing. So you could almost say it could be built into this also. There's a circularity. But anyway, and what's basically happening? So let's say this is correct, and what I'm saying is this creates what's a locking mechanism. So that's why I really like this idea, is that this creates a locking mechanism, a little lock. Where an electron can loop onto another electron, and so you could have an electron here, and well, I guess it would be over that one, and it's locked. So these two end up locked on each other because they overlapped each other and locked into each other. And so this would give an explanation for the idea of binding electrons, to create atoms, to create matter. But now, and a further advantage of this mythology is built into this, is that this creates this automatic jitter, because this open space is essentially a space eater. So with each rotation of the electron, which would be, a few million, a few billion, who knows, Planck constants of space eaten, with each spin. There's one Planck constant. Let's say this opening is a Planck constant. Doesn't really matter, but it could be 2, could be 10. Doesn't really matter too much. But it eats that much space per rotation. So essentially, the electron is slowly, this one little Planck constant at a time, moving in a direction because of this mechanism. So that creates an imbalance in the atom constantly, that pieces of it are trying to move in different directions, and that creates the isolation. So that's also what separates them, is they all have their own movement. So this one's going this way and this one's going this way, let's say, and because of that they pull on, they're always tense, so they create this tension, and which maximizes or stabilizes their configuration through that tension. The important thing that I want to get to, how this also explains something, is that this also explains acceleration. and momentum. So when an object's moving, you know, when it's got movement in space, let's say I push something with my finger and it'll move forever through space. And why does it keep moving? Well, obviously something inside of it keeps eating space. Something inside of it is consuming space. That's the only way it can keep moving. It's consuming the structure that the atom is living in. The atoms are in a structure. They're moving from one place to another place. And why are they moving from one place to another place? You know, and I'm saying that the reason why is because of this feature. So when you push something, when you apply a force, kinetic or physical, actual movement, what you do is change how many of these little constants. So if the thing was, you know, what configuration they're in. So if they're bent, you know, this is the part that's going to get a little complicated. So if they have an axis of rotation, and that's their axis, it's straight on. What's happening is if pressure is applied in a direction, say from this direction, that axis will be changed slightly. And so now they'll be eating space in this direction. So before they were eating space in this direction, now they'll be eating space in that direction. And this will be relative for every single atom in every single electron in the matter. And so every one of them that is pushed, you know, by the compression inside the atoms, they push on each other. Obviously there's forces that tie atoms to each other and enable them to influence each other, and that force will merely be transmitted through the atoms, and they all will be displaced by this tiny amount, this one little Planck constant in their rotation. And so as you push something, you basically are realigning the matter and tending to make it all point in one direction. So as you go fast enough, you'll have all of the electrons, you know, are likely to be rotating, in a tendency to be rotating in the same direction to eat as much space as possible. And if you attempt to go very fast, that will explain Einstein. It'll explain the fact that nothing material can move that fast is because it starts to disintegrate. You'll start to break the atoms into pieces if you attempt to accelerate one of these electrons or some other, I mean the matter, to excessive speed. You'll just start disintegrating the bonds that hold the atom together, because all the electrons will have to be spinning the same exact way. But anyway, the idea of this eating space thing, this rolling ball, this is what it's doing. It's just rolling, and this is creating the noise inside the atom. But anyway, the only point I'm using this to illustrate is that when people say the two-slit experiment, they're sort of just lying, not to acknowledge that photons are interacting with atoms, that atoms have electron structure, and that structure is not only moving, and it's going to be moving at different rates depending on, you know, how thick the material is relevant, right? So if I have a thin piece of material and a thick piece of material, these surfaces are going to be different than each other. They're going to hold this different static charge of electrons. And that these things have to be accounted for in deciding whether photons are in multi-dimensions, or maybe matter is in different configurations and causes photons to act differently when they travel in proximity to that matter. That jiggling matter will interact in certain patterns, in certain probabilistic ways, depending on the structure of the matter, depending on the molecular structure and the electron structure, most specifically of the surface, which we know is highly concentrated with electrons. Surfaces are highly concentrated with electrons because of static charges. So this is important. So it's a lot of electrons, and with atoms behind them jiggling. And we don't understand that might create some kind of wave interference pattern or some kind of other phenomenon. Come on, where's the more rational place to look for the gun, the murder weapon here, the creation weapon of the appearance of complexity. The complexity is in the matter. Complexity isn't in the photons. So anyway, That's probably enough for now. Yeah. But anyway, I'm just saying that this is not, it's the fact that I have invented this idea to solve this problem, and that it also works for this acceleration problem, I think is a good sign.